All right, problem number 3. In the arrow-shaped polygon below, there are right angles at vertice A. I'm going to use actually a little symbol to mark these. Vertice A, vertice C, vertice D, E, and F. And then we're given the lengths of BC. BC is 5, and so is FG. CD and FE are 20. Okay, so that's this and this. They're both marked already. And DE is 10. And we know that AB and AG are equal. Okay, so let's put a couple little hash marks on these sides to indicate that they are equal. And what is the area of this polygon? Okay, well, this one's not too bad. Let's actually divide this figure up into 2 regions. Okay, so if I draw a little dashed line here from C to F, okay, you can see that this is just a rectangle, right? So figuring out the area of that is easy, right? You just take 20 times 10, and that gives us 200 for that area. And over here, we have a triangle, right? And it's an isosceles triangle because we know that 2 sides are the same. So we also know that this angle and this angle are the same. And since this is 90 degrees, we know that this has to be 45. Okay, and this has to be 45. Okay. So we got this nice symmetrical triangle. And we don't really have we know that these legs are equal, but we don't really know the length, but we could figure it out. I'm actually going to draw an altitude on this triangle, and I'm going to draw it from this vertice A down to this side. Okay, oops. Alright, so let's call that's the altitude. So let's call that the height, okay? And if we look at the triangle as if this is the base, this from B to G, then this problem isn't too bad, okay? So, so we know that this whole side is 10, right? From here to here, because it's a rectangle, it's got to be the same as this. And then we know that this whole base, if we measure it from B to G, is 20, right? From B to G. So we know that the area of the triangle is 1/2 base times height, and so that's 1/2, and the base then is this 5 plus 10 plus 5, which is 20. So the base is 20, and the height, now we aren't given the height, but we can reason it out because we know that here we've got this altitude, and it divides this triangle really into 2 more triangles, right? And they are congruent to each other, right? Because they have a, because it's a 45, the whole thing was a 45, 45, 90 triangle, and we divided it essentially in half, so we got 2 more 45, 45, 90 triangles, okay? And and we know in a 45, 45, 90 triangle that, so this has to be 45 degrees, which makes this an isosceles triangle. The smaller triangles is isosceles as well. So we know that this leg from B down to the midpoint here has to be half, or has to be the same as the altitude, okay? And from B down to that midpoint is going to be just half of 20, which is 10, okay? So this altitude will also be 10, okay? You follow that? So this leg here from B to the midpoint is 10, right? Because the whole thing was 20, and so the altitude has to be 10 as well, because it's a 45, 45, 90 triangle, so it's isosceles, and so this side from B to the midpoint has to be the same as this side from A to the midpoint. Okay, so so for the whole big triangle, this ABG triangle, maybe I should write that. ABG is the triangle that we're looking at. Okay, so the base is 20 and the height is 10. Okay, so what do we got there? If we divide that in half, then so we get an area of 100. Okay, so we have the area of the triangle plus the area of the rectangle, and we knew that the area of the rectangle, which is CDEG, was 200, right? Just 20 times 10. And if we add those together, we get 300. So the total area is 300, and we aren't given any units, so we don't really know if it's inches or feet or miles or kilometers or millimeters. We don't know, but whatever the units are, we got 300 of those, 300 square of those, right? So so there you go. There's the answer for that problem.